Hello guys. Whoa. So right now we're going to work on these couple of questions, and yeah, it will be the end of trigonometry. I'm very happy to finish this topic. I'm very happy. So let's start. So you have this question, if tan 7 is equals to if 7 tan theta equals to 3 and cos is negative, use the use a sketch in the correct quadrant to determine the value of that thing over there. So when I saw this question, I didn't see this thing, the correct quadrant. In my mind, I was thinking 7 tan theta equals to 3. Then tan theta equals to this over this, which is equals to socket opposite over adjacent, right? And therefore, draw your right angled triangle. And then this is theta. Then you have opposite being 3, adjacent being 7. That was exactly my thought, right? And then from here you can just find this longest the hypotenuse, which I think is gonna be square root of you have 9 and 9 and 49, that is 58. So this is just how I thought. I'm like, you do this and then you go there, substitute. Very easy question, but this is not how we're gonna do it, right? Because of this and this correct quadrant thing, right? So let's do it as we are supposed to do it, the correct way. First thing first, we draw your Cartesian plane. So I'll put it here. Yes, man, that is fine. And then specify them. This is y-axis and this is your x-axis, right? So from these two now, what is happening? Before, okay, these people, they say that cos theta is negative, right? Here it is, cos theta is what? Smaller than 0, implying cos theta is negative. Now, where is cos theta negative? It is negative on only 2 quadrants and positive on only 2 quadrants. Here, this is where we have it positive, right? And then here also we have it being positive, right? But then here it's actually negative, right, on the second quadrant, as well as here on the third quadrant it's actually negative. So possibly the angle, the theta, which is the angle, it's somewhere on the second or the third quadrant, right? Yeah. So now let us focus on tan. We have 7 tan theta equals to 3, implying that tan theta equals to 3 over 7. Right. And with that being said, you realize, oh, my tangent is positive. Question is, where is tangent positive? First quadrant and third quadrant. So now trying to find where tangent is positive and cos theta, tan theta is positive and cos theta is negative. That quadrant is the third quadrant. So your angle is somewhere here on your third quadrant. That we are done with it. So, and you know that when you draw your angles, when we measure our angles, we measure them anti-clockwise. So probably gonna be some like, then you have your straight line there, and this is theta, right? But we'll come to that. Now we need to deal with this. So we are aware that our angle is somewhere in the third quadrant. What's happening in the third quadrant? Both x and y are negative, right? That could also say here we can conclude that we have something like -3 divided by -7, right? And now I want to say something. You see, for some reason, for other people, it will be confusing to see which one is x and which one is y between -3 and -7. It can be very confusing, But if ever, especially now for this problem that the thing is gonna be on the third quadrant, it becomes really confusing, right? So I'm gonna give you something that you guys know that will help you to actually not mess this up. So you're gonna go back to the old days of how I need it. So you're gonna go back to the old days of how you'd draw your Cartesian plane. So this is just a sketch of our Cartesian plane, right? And then you would have point here called point P, and this point going anti-clockwise gives us an angle called theta x, y, and then you have this dotted line which represent change in y, and then you have this the distance here, and this distance here, it represent change in x, right? So now we're from here, we was like sine theta equals to opposite, which is y, over hypotenuse, which is r, right? We were like cos theta equals to what? Cos theta equals to adjacent, which is x, over hypotenuse, which is r. And then as for tangent, ne? As for tangent, we had SOHCAHTOA opposite, which is y, over adjacent, which is x, right? So now this tells us that here we have minus 3. Let me use a different color. We have here we have minus 3 over minus 7, saying minus 7 is x, minus 3 is y. So now when we go to our diagram, we know that it's gonna be something like this, right? It's gonna be something like this. Yeah, it's gonna be something like this. You have your point right here. You have your point, say this is point P, where you have minus 7 and minus 3, right? So this right here, you have negative 3, and then right here you have minus 7. Do you understand? So now with these things that you have, it becomes very easy now. Cool. So the first thing first, we need to find r, né? To find r, the formula for r, we have r squared equals to x squared plus y squared. That is minus 7 squared plus minus 3 squared, which is basically 58. And then r squared, therefore r is equals to square root of 58. Right, so you have found r, right? So now I want to take these and everything here and resize it. So the reason I'm resizing it, it still is very important, right? And we might actually refer back to it. So yeah, now let us go and answer the question. To answer the question, we have sine theta plus cos theta divided by 2 sine theta, right? Okay, then substitution. Yeah, substitution. What is the sine? Sine is, here we have it, y over r. So we have sine, which is y, which is minus 3 over r, which is square root of 58, right? Plus minus 7 over, which is for cos, over square root of 58. Now, let me put this in a close bracket and say divided by, I'm dividing by 2, multiply by minus 3 over square root of 58, right? So now I'm gonna have minus 3 minus 7. In fact, I can just say minus 10 over square root of 58, that divided by minus 6 over square root of 58. Then you have minus 10 square root of 58 multiplied by square root of 58 minus 6. Right, so now the square root of 58, they go and divide each other, and the negatives as well. Then you have positive, then you have 10 over 6, which is basically 5 over 3, and there's your answer. You are done. Right, you are done. Also, alternatively, if you do not like messy things, you could say that sine x plus cos x to sine x equals to, you have y over r plus x over r divided by 2 into y over r, right? So then you have y plus x over r divided by 2y over r, right? Then you have y plus x over r multiplied by r over 2y, and divide. Then you have y plus x over 2y, of which of which by substitution, that is minus 3 minus 3 minus minus 7 minus 2 into, okay, yes, and then that is minus 10 over minus 6, which is 5 over 3, right? So we are done with that problem. Let's move on. For this one, we're gonna answer it the way I thought we will answer the first one, which is, now they are saying sine 32 degrees is equals to p, right? So first thing first, you need to draw your triangle, and then say this is 32 degrees, this being 32 degrees, you have, let's go here, sine 32 degrees is equals to p, which is equals to p divided by 1. So sine is opposite, which is p, right, over hypotenuse, which is 1, and by theorem of Pythagoras, this is going to be square root of 1 minus p squared, right? Now once you have done this, it becomes, and you need to show this on your answer sheet as well, and your workout is also of Pythagoras, of theorem of Pythagoras, to get this. Now your answer, the first one, they're saying tan minus 32, right? We are talking about negative angles. It is only cos that becomes positive. Cos into negative theta is equals to cos theta. Others, this remain negative. So this is negative tan 32 degrees, which is negative. Tangent is opposite over adjacent. So p, which is opposite over adjacent, which is 1 minus p squared, right? Opposite over adjacent. Yeah, that is tan. And then this one, number 2, something interesting, right? Remember when we were talking about, I forgot the term we gave those angles, but remember when we were talking about these angles of angles that are greater than 360. So because this 418, it is greater than 360, we're going to have 360 plus, we go here for 18 minus 360, 58, right? We get 58 degrees. 58 degrees equals to sine 58 degrees, so which is equals to what? We come here, remember this is a right angle triangle, you have your 90, okay, let me say this, you're gonna have 180 minus your 90 degrees, this one minus your 32 degrees, you get 58. That means this angle here It's actually 58 degrees, and you need to show it also on your diagram. So in that case, sine 58 becomes opposite, right, which is a square root of 1 minus p squared, all divided by 1, right, which is your hypotenuse. So then the answer becomes 1 minus p squared, and done. You are done with this. You have your 5 marks, and you are ready to go to the next question. The next question, they say without the use of a calculator, we have to simplify this name. So let us do that. To simplify this, we're gonna enjoy it. We're gonna enjoy solving this problem. Yeah, let's start. So where is 100 and you see this? Look at the way the questions I'm asking myself. Ne? The first question, where is 120 degrees in our Cartesian plane? Where is it? It's in the second quadrant. Second quadrant, that's where we have 90 minus theta, right? I mean, you could also use 90 plus, right? But yeah, don't complicate your life. So sine 180 degrees minus what? We check 180 minus 120, it's 60. So minus 60 degrees, right? And then for tangent 300, the angle there 300 degrees, it's in the fourth quadrant where we have 360 minus theta. So here you realize we have 360 minus 60 degrees. Ne? Oh my god. Yep. And then denominators, negative angles. Cos is the only one positive, so we have cos 60 degrees, right? Multiply by tangent 222 degrees Celsius. Oh no. 225 degrees. It is found where? 225, we haven't crossed 270, meaning we haven't went to the fourth quadrant, and we are above 180 degrees, therefore we are in the third quadrant. And in the third quadrant, that's where we have 180 degrees, right? 180 degrees plus, so this is gonna be 180 degrees plus 45 degrees. You do the math here, you're gonna get exactly these, right? So yeah, after here we cook something powerful. So the numerator, that is sine 60, a positive one, because sine is positive there. Here it's gonna be a negative tan 60 because tangent is negative there. You have your sine 60. Oh no, it's cos. You have your cos 60 multiplied by tan, it's positive there, so we have tan 45, right? And then you realize, by now you must have realized that these are special angles, special angles. So you can just draw your two triangles. You will just draw your two triangles and start naming them. So this one, say this is 30 degrees, right angled 60 degrees. This is 45 degrees, 90, 45 degrees. So here sine 30 is 1 over 2, it's half. Then here you know it's square root of 3. Here it's 1, it's 1. Here you know by Pythagoras, square root of 2. Once we have done this, we come here and solve this without the use of a calculator. So sine 60, this is 60, opposite over hypotenuse. So that is square root of, that is a square root of 3 over 2 multiplied by negative tan 60, tan opposite over adjacent, so that is square root of 3 over 1, right? Opposite of adjacent 60, right? Then we have all over cos 60 adjacent over hypotenuse, so that's 1 over 2 multiply by tan theta, tan 45, it's opposite over adjacent. It doesn't matter which 45 you are talking about, so this is just basically 1. Okay, let me just say 1 over 1. Yeah, cool. When you multiply your numerators, you will have a negative. Square root of 3 times square root of 3, that is 3, right? And then you will have divided by, we are done with the numerators. Now we come to the denominators. Divided by 1 over 2, right? Oh no, actually, we are not done. Look, here, I'm sorry. So here you have square root of 3 times square root of 3. That's going to be what? It's going to be 3 over 2. Because 2 times 1, that is 2. Then you have divided by 1 over 2, which is negative 3 over 2 multiplied by 2 over 1. And then the 2, they divide each other. And then the last value you have, it's what? It's minus 3. And for our satisfaction, we didn't use a calculator at all. For our satisfaction, we're gonna go to our calculator just for the sake of, our happiness. We don't want to be stressed, even after we have left the examination room. So I'm gonna put these on a calculator as they are from the question. And then tan 225, right? Look at the answer you're getting. It's exactly minus 3, which is what we got. So, okay, now we are proving this identity. It's gonna be a quick one. Don't stress about it. So, the most important thing that I did mention about proving the quantities is that there are cases where you can, it doesn't matter, you can literally use both sides. You can use the right hand side to make it look like the left hand side, or no, not all, and you can also use the right hand side and make it look like the left hand side. So both sides, you can work with them, yeah. But also there are cases where only one side is possible, right? There are cases where you only have one side possible. For example, you have a big fraction here with some messy trig functions here, and then on the side you just have one trig function, which is cos theta. Right? There's no way you can actually take cos theta and try to, I mean, you could try, and I have confidence in your intelligence, but if you can do that, I respect you very highly, because now you will have to try it, man. You will see that it's a waste of time. You're trying to save as much time as possible here. So there are sides which are much easier to solve or simplify relative to the other side. For example, in this one, there are left hand side, right, left hand side, it's much easier to solve or simplify compared to this right hand side. So we're gonna use it and try to prove that this left hand side is gives the same thing we're getting there on our right hand side. So cool, let's start the work. So we first thing first. So here we have cos squared theta. We also have sin squared theta. I thought when I saw that, I thought I'm seeing one, but there's a minus, so we're not adding them. So here I'd really so I don't know, we're gonna try to change this into cos now, because I'm seeing many causes. So we're gonna try to change this into a cos, right? I don't know, maybe you could try change this into a sine, and hopefully, I don't know if it will lead us to the same answer. But yeah, and try it on your own time and see if you get the same answer, just for practice. So for this one, we have cos squared x minus cos x minus, then open bracket, 1 minus cos squared x, right? close bracket. And then you have 2 sine x cos x plus sine x, right? So now we just distribute the negative. You have cos squared x minus cos x minus 1 plus cos squared x, right? And then here 2 2 sin x cos x. Yeah, when you guys get to grade 12, there's an identity for this. Yeah, but so here the cos squares, we add them together, we have 2 cos cos squared x minus cos x minus 1. Then you have 2 sine x cos x plus sine x, right? So this is what you have. So now you realize that okay, I want to give you guys this tip. There's this tip, it helped me a lot. You see, sometimes when you have to factorize trigonometric functions, it can be really difficult to visualize the whole thing, right? So what I do for my sake, on a piece of paper, right, this one you don't need to show it to them. On a piece of paper, I would say let cos, I mean, you can also show it on your working, but yeah, but let cos x be y. That means then I have 2y squared minus y minus 1. Is it minus 1? Yes. So I took this, let cos x be y, and then yeah. So now there is a method that I taught you guys when we talk about factorization, that when you have a number like this and you can't picture it, like how to factorize it, then you multiply the coefficient of y squared by the last variable, by the constant, right? So that is 2 multiplied by 1, which is equals to 2. And this 2 multiplied by 1, it has only 2 factors, which is 1 and 2. And those two, when we add or subtract them, we can get the middle coefficient, which is minus 1. So how are we going to do that? You have 2y squared minus 2y plus y minus 1, right? So so now from here, you can group these two. They call it factorization by grouping. So you take the common factor, which is 2y, then you have y minus 1, then plus 1 into y minus 1. You have the common factor there, which is y minus 1, and then you have the remaining pieces, 2y plus 1, right? So you already see now, okay, that since you set that y, you set that cos x to be y here. This is what we set here, right? You going back to substitute now. So you have cos x. Let me use a different color just so that it's visible. So you have cos x minus 1, right? And then you have 2 cos x plus 1, right? And then we do this, we factorize this one, we get common factor here is sine, so sine x into, you have 2 cos x plus 1, right? You realize that common factors, they divide each other, right? They divide each other, so remove this. And then after those common factors have divided each other, what you are left with is just cos x minus 1 all over sine x, which is also cos x over sine x minus 1 over sine x. Now realize you have the minus sine x, minus 1 over sine x. You have it. What's the next thing? It's for us to make this be 1 over tan, right? So let's look at this now. Tangent tan theta equals to sine over cos theta, right? This is what? This is tan theta. But here we have cos over, right, over sine. And then 1 over tan theta, it's going to be 1 divided by sine theta over cos theta, which is 1 multiplied by cos theta over sine theta, right, which is exactly what we have right here. Ne? So you'll see that then you can conclude your matters to say therefore, right, to say therefore you have 1 over tan x minus 1 over sine x, and therefore right left hand side equals to right hand side. And you are done. You have your 5 marks. Yeah, you are busy cooking. Cool. So let's jump on to the next question. This question is the last question for the question that I selected. There's another one for those area sine cosine rule. We'll get to them. Let's focus here. Here we determine the general solution. I want to say there was a time when I was doing general solution, I was like, these are type of a question that I wanted to do. Because it really helps to know how to solve these kinds. Like the way I taught you guys, you'd find your reference angle whatsoever, and then but here, how do you start to find your reference angle? That's a big question, right? So you don't. So for sine and cos, remember those cofunction. You can turn sine into cos, you can turn cos into sine, right? So say we turn cos into sine here. Yeah. If we turn cos into sine, that means you have sine 5 theta equals to sine, then it is 90 degrees minus theta minus 40 degrees. All right, then which is sine 5 theta sine 90 plus 40 degrees minus theta sine 5 theta sine 130 degrees minus theta. Right, so now with this that you have, whenever you have sine, the next step, this is the next step, you would then say you have 5, say maybe therefore 5 theta equals to 130 degrees minus theta, right, plus 360 degrees times multiplied by k, where k is an element of integers. Right, so now this is just how you do it. It's just like when you have 2x is equals to 2 I don't know, y plus k, right? You just divide by 2 both sides and you are left with x is equals to y over k. It's basically the same idea. Yeah. And now when you look at the signs, the sign here is positive, which you raise a question where is sign positive, the first quadrant and the second quadrant. So therefore, for this problem, we just this is the solution that you would find in the first quadrant. Now you take this, transpose your theta, you get 6 theta because it becomes positive, and then you still have 130 degrees plus 360 times k, right? And then 130 divided by 6, you are getting 21.67 degrees plus, I think that one, oh no, divide by 6, then 60k, right? This is the first angle that we get. Yeah? And now the next thing we do is, where is sine theta positive in the second quadrant? So now you have 5 theta equals to 180 degrees minus, right, 130 degrees minus theta, then plus 360 times k, and then where k is an element of integers, right? So now you have 180 degrees minus 130 degrees plus theta plus 360 degrees times k. You transpose this onto the other side, it becomes negative, and therefore you have 4 theta. Then you do the subtraction here. I think that will be 50 degrees plus 360, right? And then you do your math here. Theta is equals to 50 divided by 4, that is 12.5 degrees plus 360 divided by 4, that is 90 degrees multiplied by k, and you are done with the solution. You have your 6 marks, and overall you have your 29 marks, and you are done. All right, so this is how you do this question, eh? And then also, of course, I did say there are many methods, né? So another alternative would be for you to change the sign into cos, right? And how you would do that, this is how you would do that. You would then say you have cos into then 90 minus 5 theta. Then this one you just leave it as it is, cos theta minus, right, 40 degrees. Then the next step, since there is nothing to add or subtract, the next step you say that cos 50 degrees equals to theta minus 40 degrees, then plus 360 k element, right? Yes, so now I'm gonna do this very fast now. You can do it by yourself very slowly, and yeah, check if you get the same answer as me. So I'm taking this theta to that side, it becomes negative, right? So I have negative 6 theta. I'm taking this 90 to that side, it becomes negative as well. So negative 40, negative 90, negative 130, negative 130, right, plus 360 k. Then I divide by 6. I think we're gonna get negative 21.67 degrees plus 60 times k, right? This is in the first quadrant. Another question, where is cos positive? Fourth quadrant. So then you also have 90 minus 5 theta equals to 360 degrees minus theta minus 40. So these you put them in a bracket, plus 360k, 360 degrees multiplied by k, and then k element of a real number. So now here's what we're gonna do. Okay, minus theta plus 40, right, plus 360 k. So this theta is negative, right? When it goes that side, it becomes positive, and then you end up having a value that is what? You end up having a value that is negative. So you're going to have negative 4 theta. So now we have 360 plus 40 degrees minus 90. This 90 here, it goes that side, minus, we end up with 310. Yeah. And then you have plus plus your 360. Then you divide by negative all over. Then theta becomes 310 divided by 4. You are getting negative 77.5 minus 90 times k. Then this becomes your angle for cos if you are using cos, and you will get your 6 marks. But please do it step by step. Yeah, well, you don't want to miss any marks, and include the k as an element of a real number. Cool. So it doesn't really matter. You could use sine, you could use cos, and you will still be fine. You would still be fine. Yeah. Let's move on to the next question. Yeah, don't know if I'm moving very fast or the pace is fine, but yeah, cool. This question asks a very simple question to say, what is angle BDC? This one, you add the two, you get the angle. So therefore angle is what? 70 degrees. Then calculate the length of BC, right? Look, you have 5 and 20. You have 50, you don't have this. Once you have this and you have this angle, of course, once you have this, you can find this. You already see why I'm going sine rule, right? So sine rule, it says that you would say that AD over sine ABD equals to equals to BD over sine what? Sine BAD, right? So now, because we are trying to find what? We are trying to find BD, so we're gonna multiply everything here by what? By sine. We multiply everything here by sine BAD. When you do that, the answer you get, it will be BD equals to AD sine sine BAD divided by sine ABD. When you do your substitution, this is 5 sine the sign here, sine BAD, that is 50, and then that other one, it is 20. Right, you go press your calculator. 5 times sine 50 close bracket, you're gonna sine times sine 20, right? And we are getting the value as what? The value is 11.2, right? After you have 11.2, you have this length as 11.2. You can now use what? You have 70 degrees here, right? And you are looking for the opposite side. You have your hypotenuse, so we are going to use sine to say sine BDC is equals to opposite, which is BC, over hypotenuse, which is BD, right? Substitution, it's sine. Before substitution, we want to make BC subject of the formula, so we multiply by BD, right? Therefore you have BC equals to BD sine BDC, right? That is 11.2 2 sine 70, and then 11.2 multiplied by sine 70, 10.52, right, meters. Now here I should put meters. Then you have your answer. If you are done with this question, everything is going well, right? Cool. Here's another question. This is the last question we have. So for this question, what we have to do is, the first one say determine the perimeter of the octagon, right? So this octagon composes of, remember, it has 8 equal sides, right? It has 8 equal sides, right? And they are saying this is radius and this is radius, right? So now when you have this, it becomes, let me try to log this photo. Yes, lock it. Yeah, it becomes very easy now. We have one, and it gives us some idea. Yeah, we're like, okay, maybe I need this sides, and since all of these 8 sides are identical to AB, if I find the length of this and I multiply by the length, I multiply this length by 8, I will have parameter. Cool. So we do that very nicely. I have the 2 adjacent there. Remember, we can use sine rule to find sides, yeah? We can use them, but yeah, we can use them. You can actually even use sine rule here. You can even use cosine rule here. You can, right? I'm gonna use cosine rule, but you can also use sine rule to find the length of AB, because both sine rule and cosine rule involve sides. Another thing is this. If I draw straight line all going to the center, so I'm drawing triangles here. I'm forming triangles that are identical to this triangle, right? And then here, this angle right here, it's 360 degrees divided by 8 equal, well, let me see, 1 2 3 4 5 6 7 8, well, divided by 8 equal triangles, and then yeah, so those 8 triangles, right, they help me. I could say that I have 360 degrees divided by 8. I'm getting 45. That means each of those angles, they each have an angle of 45 degrees here at the corner, right? All of them. Right, so now I have my angle. I have these 2 sides. I can find the side. So I will say AB squared is gonna be equals to R squared plus R squared minus 2R times R cos 45, right? That is the cosine rule. So I have 2R squared minus 2R squared, and then cos 45, right? Cos 45, then it is 2 square root of 2 over 2, right? Yeah, so now now what I do have, I can say this is what, let me see. Okay, I have a common factor. Let me just take out a common factor. Okay, before I do that, I have 2R squared minus 2, this 2, it's going to divide with this 2, so then I have R squared minus square root of 2, right? And with that being said, yeah, the 2 divides the 2. Cool. But this is not minus, this is multiplication, so everything is still fine. Then I have R squared into 2 minus square root of 2. This is AB squared, and therefore AB, it's gonna be r square root of 2 minus square root of 2, right? Now that is AB. So I'm therefore saying, therefore, the perimeter will be 8 times AB, which is 8 times r square root of 2 minus a when I say yes, square root of 2 minus square root of 2. Right. And there we have it. You are done. Now we calculate the area of the octagon. Cool. So as for the area of the octagon, let's go back. I have the side, ne? You have, and I have my two adjacent side. I'm calculating in terms of r as well. I have these two adjacent side forming an angle of 45 degrees. I can use area rule to find the area of triangle AOB and then multiply that by 8 to have, because remember we have 8 identical triangles. So area of octagon is gonna be 8 multiplied by area of triangle AOB, which is 8 times, now the area of the triangle, it's going to be what? Half multiplied by r multiplied by r multiplied by sine 45 degrees, right? Which is 8 multiplied by, or maybe let me just say that 8, then I have 4 multiplied by r squared multiplied by the sine there. So sine 45, it's just like cos 45, that is square root of 2 divided by 2, right? And then I multiply the 4 by 2. So what's going to happen is that this 2 will be gone, we have 1, and then here we'll have 2 after the division has happened, and therefore the final answer is 2r squared square root of 2. Let us see. It matches exactly 2 square root of 2r squared. Now, centimeter squared. We can actually even write it like them to say this is square root of 2 r squared centimeter squared. And then yeah, just like that, my friend, you have, since maybe they said centimeter squared, we could also say centimeters here. Centimeter, yeah, just for the sake of perfection. Yes. Let me see. So yes guys, so that is the end of this video. I hope it really helps in, I hope it really helps in whatsoever way possible with whatever you guys may have been struggling with in relation to trigonometry. So yes, I will see you guys in the next topic, right? I will see you in the next topic that I'll be recording, and do say if you like the video, yeah, and tell me where to improve also if you have any suggestions. Thank you guys, I'll see you.